right, guys. So last class, let's talk about little more about last class. So last class we have studied operator precedence parser, and for that one we have studied operator precedence grammar. And we have also seen if a grammar is not operator precedence, how can we make that grammar to operator precedence? Using actually one of the rule of the Chomsky. Okay. So as long as start symbol does not derive the epsilon, we can remove other epsilon symbols from other products, and finally actually we can convert almost all the grammars, not all the grammars, but almost all the grammars, all the normal grammars, the most frequently used grammars to operator precedence. Now we'll stop last class over there. So I have given you a homework. Did you solve the homework? Did you solve the homework?
Sir, to parse the string.
Yeah, to parse the string using this graph, constructing this graph. I have already constructed the graph, and I have also constructed the table, both. So I ask you to recompute the string again using this table. Did you do this? No.
Sir, এটা বুঝি নাই আসলে।
বুঝেন নাই? Why don't you understand?
String এর স্যার string এর সাথে to find the path এটা পারি না।
I don't understand your. What didn't you get? What didn't you get?
Sir, the homework I didn't understand. Using
Homework is
table to
this string,
yeah.
and you have this table. You have this string and this table.
Yes, sir.
You have to parse this string. You have to parse this string using this table. Same rule. If stack is greater than buffer, pop. If buffer is greater than stack, then push. So why don't you understand the homework problem? Huh? Uh-huh.
স্যার সলিউশনটা দেন তাহলে বুঝতে পারবো।
I need to provide the solution.
Yes, sir.
Okay. এটা ফাঁকিবাজি হয়ে গেল না একটু? স্ট্যান্ডার্ড ফাঁকিবাজি।
No, sir, I tried it at home, but I didn't
Simple.
understand.
Simple. Same procedure. Same procedure. The same procedure. So what is the grammar? Grammar is like this. E derives E plus E or E star E or ID. So what is my string? So what is the string we're trying? We're trying ID plus ID star I. ID plus ID star I. What is the string? This is my grammar. This is my grammar, and this is ambiguous. I'm going to breaking this ambiguity using this table. And what is my string? I want to parse ID plus ID star ID. So we have stack. We have stack. And let's write it over here for creating the parse tree. Let's write it. This is my F. This is my G. Am I right? F is my stack and G is my buffer. Initially, I'm pointing to the first letter in the buffer. Is it clear to you guys? Yes, no?
Yes, sir.
Yes, sir.
Yes,
Yes.
sir. Yes, sir. And what is the first Entry in the empty stack. What is that one? Huh?
dollar.
Dollar.
Dollar. Good. Good. Dollar. Now F dollar. What is the value of F dollar? 1. And
One.
what is the G? GID. What is the value of
GIT.
GID? 6.
6.
Which one is bigger?
GIT is bigger.
So buffer is bigger than stack. So what I'm going to do?
Push.
Push. So I'm going to push this. Then this one becomes F. So here I have FID. FID has value 5. And here I have G plus. So what is the value of G plus? G plus is 3. Which one is bigger?
So G plus is 2.
G plus is 2. Yes, sorry. So which one is bigger, FID or G plus?
FID.
FID.
So what I'm going to do?
Pop.
Pop. So I'm going to pop this one and I'm going to use the rule. So ID, there is only one rule. ID would become PE. Then here I have F dollar. F dollar has value 1. And here I have G plus. G plus has value of 2. Which one is bigger?
G
G
plus.
plus. So I'm going to push. Then and move the look ahead. Now here I have GID. GID has value 6. And here I have F plus. F plus has value 3. So which one is bigger? G is bigger. So I'm going to push. Push. Then I'm going to move it over there. So what is there? I have
Star.
G star. G star and FID. FID is plus. And G star is
bigger.
4. So FID is bigger. So I'm going to pop.
Pop.
So it would become E. Now here I have F plus. F plus is value of 3. Sorry, F plus is value of 3. Yes. And G star has a value of 5. Which one is bigger? G star is bigger. So I'm going to push. I'm going to push star. Then I have moving over here. And then there is a dollar. Now I have GID. GID has a value of 6. And here is F star has a value of 5. Which one is bigger? GID is bigger. So I'm going to push. I'm going to push. Then here I have G dollar. G dollar is 1 and FID is 5. So I'm going to pop. It would become E. Then I have F star. F star is a value of 5 and G dollar is a value of 1. Which one is bigger? So I'm going to pop. So this whole thing, I'm going to use this product. This whole thing would become E. And finally I have F plus. F plus is value of 3 and G dollar has a value of 1. So I'm going to pop. So this whole thing would become finally E. Finally I am meeting dollar and dollar. East is meeting west. So accept. This is the case. Same thing. Instead of doing actually using the operator precedence table, at first we are going to create a graph. From that graph, we are actually creating a new table of value. And what is the catch? Whenever we have directly use operator precedence table, we have for an operator, we have n square entries. But in this case, how many entries are there? For 4 operators, how many entries are there?
4 into 2.
2 into 2.
4 into 2.
4 into 2. So actually, if operator number is n, my complexity would be O to the power twice n, much lesser space. This is the space complexity. On the other hand, in the previous case, whenever we have operator number n, I have operator number of n square space. So what is the leverage? Leverage is huge. From n square, from a quadratic complexity to we come to a linear complexity, and that is wonderful. That is wonderful. Linear algorithm means one of the best practice algorithms. Sometimes we get logarithm algorithm, but hardly we can get logarithm algorithm. So linear algorithm is the best algorithm in terms of space. And I don't know whether it is possible to have, so it is impossible to reduce the space to logarithm algorithm. Time complexity might be sometimes logarithm, but space would never becomes logarithm. Quite absurd. I hardly know any algorithm which is space complexity. Because it is absurd. If I have n number of inputs, definitely I need at least linear algorithm. Am I right? কথা কি বোঝা গেছে এটা? If I have 10 numbers, definitely I need 10 cells. How can you come up with 2 or 3 cells? It's quite impossible. So space complexity would never be smaller than linear. So it is the best practice of it. It is not Poisson, it is actually OM. Actually, the space is twice, and complexity is OM. Do you have any query?
জি স্যার, একটা কোয়েশ্চেন আছে
Please go ahead.
স্যার। এটা টার্মিনেশনটা কিভাবে হচ্ছে স্যার? ডলারটা
এই যে এখানে বাফারেও ডলার পাচ্ছি, আবার লুক অ্যাহেডেও ডলার পাচ্ছি।
তখনই অ্যাকসেপ্টেড।
দুটা, হ্যাঁ, দুটা ডলার মানি, $2 meeting each other means in compiler construction they are accepted. There is no error.
ঠিক আছে।
Alright? আচ্ছা, আরেকটা স্মল থিং, স্মল ইস্যু। So আমরা এই schematic diagram, we have shown this schematic diagram. Can you remember? We have shown this schematic diagram. Am I right? We have shown this schematic diagram. So এটা হচ্ছে গিয়ে, this is kind of an algorithm. This is kind of algorithm. And what is the gist of our algorithm in this case? What is the gist? The input buffer, we know what is input buffer. We know what is stack. We know what is table. And what is my algorithm here? What is my algorithm?
PUP bottom-up parsing?
No. What is this algorithm?
stack.
Operator precedence parser. What
Yeah,
is
but-
the algorithm? Just 2 lines. We know
Right.
the algorithm. What is that?
Sir,
When,
push pop button না?
yes, when stack is greater than
Stack is greater than buffer, we pop.
buffer, that time we are going to do pop. And when buffer is
Buffer is
greater than
stack.
stack, push. So this is the 2-line algorithm. Now how you are going to implement it, it is up to you. But this is the algorithm. Simple.
কোয়েশ্চেন স্যার।
All right. Oh yeah, go ahead.
স্যার দুইটা যদি সমান হয়?
Twitter Shamana, then there is a problem. That means if actually in your operator precedence table to have same precedence. So we have derived this actually using this table, right? Using this table, right? We have derived the graph using this table. Am I right or not?
Yes.
In the graph, if 2 operators are same, definitely that is an error. Definitely that is an error. That means it is not parsable. Did you get it?
বুঝতে পেরেছি।
এখানে in this table, in somehow if any entries there is an equal sign, definitely that means it's an error, and you cannot parse it using this table. On the other hand, if a grammar is given and if you convert that grammar to this table, still if you get equal sign and if you are correct, then that grammar is not also possible to use. Okay, but if I give you a question that this grammar is operator precedence grammar and it is parsable, if you find the equal sign, that means there is some error in your calculation. Did you get it, Farhim?
জি স্যার।
Okay. But it happens sometimes. Question might come where you will see the 2 entries are equal. Might come. We never know. So let's start today's class. Today's class is very, very important. So let's start. Very important class. So we have started actually the bottom up parser. We have started the bottom up parser. It is something like this. We have bottom up parsers. Bottom-up parsers. And it is also, what is the alternate name for bottom-up parsers? SR parsers. Am I right?
Yes, sir.
Why those are called SR parsers? Because
Shift reduce.
they used stack, and they have shift. Shift is nothing but what operation in stack?
Push,
Push. And they have
reduce.
reduce, which is nothing but forward. Then we can classify the bottom-up parser into two large categories. Number one is actually operator precedence parser, and second one is LR parsers. LR parsers. Then actually we can classify LR parsers into four broad categories. LR parser into four broad categories. The first one is called LR0. Second one is called SLR1. Third one is called LALR1. And fourth one is called CLR1. LR0, SLR1, CLR. Did you get it? Acha. So always remember, SLR1 parser is more powerful than the LR0. LALR1 is more powerful than SLR1. And CLR1 is the most powerful parser in the market. You might argue, just sir, how about CLR2? Instead of, so you understand what is this number? What is this number? 1, 2. What is
Look
this
ahead.
one? These are look ahead. Good. That means before taking any decision, I'm going to consider only one single entry in the buffer. And whenever zero, it means whenever I'm taking any decision, I'm not going to consider any entry in the buffer during taking decision. So you might argue, just sorry, CLR2, CLR3, CLR4, are they powerful? Yes, they are powerful. If you increase the look ahead, definitely they are becoming more powerful. But if you consider the genre, the family, then CLR1 is the most powerful person. Okay? Do you have any query? So this is the rate of increment, power increment. Power increment. So today we'll study LR0. So remember, LR0 and SLR1, they used one special technique that is called LR0 items. And LALR1 and CLR1, they used another special technique. They are called LR1 items. Okay, that's it. Do you have any question you can ask?
So what does LR refer to?
You should know. Yes, we have already discussed what is LR refers to. We have discussed it before. So let's start. So let's start with LR0 parser. What is the first step? Can you tell me, anybody? What is the first step? What is this first step? You people's analogy is still very weak. Do you know what is the meaning of analogy? Do you have any idea what is analogy?
Sir, L for LMD.
But what is the meaning of analogy? What is analogy? Do you know the meaning of analogy? This word, analogy.
So the
The
abstract
ability
idea.
to do analysis.
No, that is not true. It is not analyzing. It is not analyzing. It is different. Analogy means finding similarity between two distinct things. For example, if I say cow and goat, what is the similarity between these two? What would be the first observation?
GOTO. Whole leg.
Both are quadruple. Both are quadruple. Am I right?
Yes, sir.
You know what is the meaning
Yes,
of
sir.
quadruple? Both are
Yes,
quadruple.
sir.
So this is an analogy. That means finding the logical similarities. Whenever anybody see any infant see a cow and goat, the first thing that come to his or her mind is they are both quadruple. So this is a called analogy. The same way, if you make an analogy between LR0 and LL1, then what is the L? They should be same. Am I right? So what is this L? You already given the answer, Samira. Parsing from,
Sir, LMD.
scanning from. No, 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 no,
Left.
no.
Scanning
Completely,
from left.
completely blunder. LL1, what is the first L?
Left to right.
Left to right, scanning from left to right,
Yes.
scanning from left to right. Same thing. That means also in this parser we're scanning from left to right. In fact, all the parser we always scan from left to right. What do you think? We always scanning from left to right. Deki, come on. How intelligent you people are. We can make parser, we can scan from right to left. No problem about that one. But why always we scan from left to right? How intelligent you people are. Let me guess. Why we always scan from left to right?
Because we write from left to right.
Not we. Yes, the English
Yeah.
speaking people and Bengali speaking people, maximum speaking people, they always start writing from left to right. And as these
Also
parsers are
read
made,
from.
yes, but there are languages which are written from right to left, like Hebrew,
Yeah,
Arabic,
like
written
Arabic.
from
Yeah.
Arabic and Hebrew, both. All the actually Semitic language written from right to left. But in Indo-Aryan and the uh, Romantic languages, they are written from left to right. As these parsers are made by all the Western people, maximum scholars are from Western people, and some contribution from Indian people. So that's why they always scan from left to right. I believe if, and it is a practice, it becomes a norm. I believe some Arabic guys, if they come up with this kind of parser, they definitely parse from right to left. So please remember. So it is not a big deal. You can easily convert any parser from left to right to right to left. It is possible. But the most important point is this. What is this R and what is this L?
RMD and LMD.
No. Wrong. Wrong. This one is what? This L is what? This L is what? LL1, this L is what?
LMD.
This L is LMD. Good. But how about this R? We have already discussed this. What is this R? Reverse of RMD. This is not RMD. Reverse of RMD. Because LMD and RMD both are top-down process. Am I right?
Yes, sir.
LMD and RMD both are top-down process. But this parser, this LR0 parser is inherently bottom-up. Yes, we are going to do RMD, but reverse way, so that we are going from bottom to up. Did you get it? And I have also given you the example of this. Please gone through that lecture. Then you are going to understand the difference between RMD and reverse of RMD. All right?
Yes, sir.
Please gone through that lecture. Then it will become clear. I do not want to discuss it today again. And how about this one? Look ahead
One
is
look ahead.
1. And how about this 0? Look ahead is 0. So this is the meaning of LRZ. Okay. Now, In the top-down parser, especially in LL1, we have learned a concept. What is that concept? In top-down parser, we have learned a concept. What is actually called fast and follow. That is called fast and follow. Here we are going to learn two concepts. Here also we are going to learn two concepts. Those are called closure and GOTO. So we can say two fundamental concepts in part. Two fundamental concepts in two fundamental concepts in LR parsers. One is called closure, denoted by this dot symbol. Second one is GOTO. This is denoted by this arrow. The two concepts are important. One is closure and another one is GOTO. So let's start with closure. The concept one called closure. Let's assume my grammar is like this. SDRS, SS, or SDRS. Okay. Did you get the grammar? Sing two products only. SDRS, SS, or A. Okay. Now, when I write SDRS dot SS, when I write SDRS is the, and when I write, can you find any difference between these three? These three. Can you find any difference? Anybody this? Anyone?
Position of the closure.
Good. Position of the closure. Then what is the meaning of first one? What is the meaning of first one? You can say,
That the
we can say like this. We don't see anything and expecting yes. Did you get it? Because just consider the right hand side. In this first one, first example, what is just immediately left of this point? Just consider the right hand side. What is immediately before this dot?
GOTO.
Just right hand side. It's those arrow. This just forget about. Just consider the right hand side. Just immediately before this dot, what is there? Nothing.
Yes, sir.
Nothing. Am I right? Immediately before the closure, there is nothing. That's why we have written, we don't see anything. We don't see anything. And just immediately after closure, what is there?
Yes.
So we are expecting S. Did you get it?
Yes, sir.
Okay. Now how about the second one? What would be the second case?
PCS and expecting a
We
PCS.
see S and
expecting
expecting S. Good. And how about this one?
PCS.
This one? How about this one? We see
Yes, I'm expecting nothing.
we see SS ক্লোজারের পুরোটুকু যেতে হবে। যখন আমরা ফার্দার যাব লুক অ্যাহেড সবসময় একটা করে ক্যারেক্টার ক্রিয়েট করে। So whenever we are going to write, we are considering only one letter, but whenever we are going to left, we are going to take everything. Did you get it?
Yes, sir.
So we see what SS and
Expecting
expecting what? Expecting what?
nothing. Dollar.
No, expecting, that means we are done with seeing all the letters in the right hand side. We are expecting a reduction. Did you get it? That means we have seen the whole right hand side. Now we can convert the right hand side to left hand side. Is it clear to you guys?
Yes, sir.
That means we have seen the whole right hand side. We don't expecting anything more. So the whole right hand side we have seen. Now we can convert the right hand side to left hand side. It is also called final item. Did you get it?
Yes, sir.
Any query? Now tell me. So what is this? What is the first part? How can we get this information from? What is the first part? How can we get this information from? Whatever we have seen so far. How can we get this information from? Come on. How can we get that in? Huh?
From scanning.
No. No, from scanning. Number 2 is from scanning. It is fine. This is from scanning. So scanning information comes from where? Scanning information coming from where? Come on. You people are very funny. Scanning information coming from where? Buffer. Good. Speak loudly. So the number 2 part information coming from buffer. And how about this? This is means so far whatever we have scanned. From where did we get this information? বাকি তো আর একটাই থাকে। হ্যাঁ?
Stack.
Yes, of course. Stack. Because this means in the stack right now there is a S. And I am expecting another S from the buffer. How about this? It means initially my stack is empty and there are 2 S out there. I'm here. And how about this? It means in the stack we have SS and buffer might have something. We don't know. So this is the cases. Is it clear to you guys? কথা
Sir,
বলেন।
expecting reduction টা বুঝি নেই।
Expected reduction হচ্ছে গিয়ে what is reduction? What is reduction? What is reduction? What is reduction? What is expansion and what is reduction? Derivation and reduction, what is the difference? What is derivation and what is reduction? If this is the product, S derives SS, then what is the derivation and what is the reduction? If S become double S, then this is called what? Derivation, am I right?
Derivation,
S
yes.
becomes double S. This is the derivation.
Oh,
What is
sir, opposite reduction.
opposite is called reduction. That means we get 2S, we convert it to single S. Am I right?
Yes,
So
sir.
this is nothing but top to down process. This is nothing but bottom up process. In TTP, we use derivation because we are top down. And in bottom up, we use reduction because we are bottom up parser. Is it clear?
Yes, sir.
Yes, sir.
Okay.
Yes.
Now Let's assume something like this. What is your goal? Your goal is you try to derive double S to single S. Did you get it?
Yes,
You
sir.
want to derive double S to single S. You want to do this reduction. When you can do the reduction? Tell me. If your closure operator at the beginning, can you do reduction?
No, sir, because there
Because
is
I did not see
nothing.
anything. I did not see anything. There is nothing in my stack. What I am going to reduce? Am I right? So it is not
Yes,
possible.
sir.
Now, if in the middle I have the closure operator, can I reduce using this product?
It's already in the reduced form.
No. Oh, let's assume.
Sir, S.
Listen carefully. At the very beginning, there is a closure operator. That means in my stack there is nothing. I'm expecting to see a S. So can I reduce? Of course not, because I did not
No.
get any S yet. Now, if in the middle there is a closure operator, can I reduce? No, because I have seen only one S. I require two S. So whenever in the middle, we cannot do reduce. But whenever the closure operator at the end, that means I have already seen two S. And these two S are inside my stack. So definitely I can reduce right now. Did you get it? Then I
Yes.
can reduce. So in this case, my stack is empty. In this case, my stack has only one S. In this case, my stack has two S. So then I can reduce this 2S, remove 2S, and put on single S. Is it clear to you guys?
Yes, sir.
Okay. Now let's go to part. So what is go to? That is also important.
Sir, a question,
Yes.
sir.
Okay, of course.
Sir, ক্লোজারটা কি রিপ্রেজেন্ট করছে স্যার?
Closure is actually representing. So whenever we start, actually, I'm going to take a grammar. Don't worry. I'm going to take a grammar that actually I start making a DFA for parsing. For our parsing, bottom-up parsing, we are making a DFA out of that grammar. And we are going to make the DFA in such a way so that we can cover all the possibilities of movement of that grammar. So in that DFA, each state is nothing but closure. Did you get it?
In the DFA?
I'm going to show you. Wait, just 2-3 minutes. I'm going to show you. Let's clear the code to part first. So reduction is this, derivation is this, and you understand what is closure. And whenever the dot at the rightmost position, we have nothing to expect, we can reduce, that is called final item. Now let's go to GOTO. Let's take a GOTO. So let's take this part. This one. Okay. All right. So initially, let's consume like this. Is giraffes. Here is my. Here is my. Here is my
ক্লোজার?
closure operator. This is my closure operator. Then, actually, then what happened? I'm seeing a what? I'm seeing a
A.
terminal. I'm seeing a terminal. So if you consider like this, so this is my state. Let's assume I have come this state from somewhere. Now I have something in the stack, and right now in the buffer I'm encountering a which is a terminal. Then what happened? Just removing this terminal from the buffer and put it inside stack. This is nothing but GOTO. Did you get it? This is called GOTO. From here to this is my stack. This is my terminal. Did you get it? Removing a terminal from buffer, removing a terminal from a buffer and put it inside the stack is called GOTO. Did you get it?
Yes, sir.
So after putting this one in the stack, what would be my rule? I'm going to a new state, and in this case, I have already seen the A. So it would be like this. Did you get it? So this is the case.
Yes.
So this is called GOTO. These are the two operations. Remember. Same way, let's take this. Let's take this. Uh, so this is the GOTO operation. Okay. Now let's take this. S derives S. Now what happened? Initially it is like this. This is my state. I might come from some places to this state. Then what happened? It is GOTO on A. Then if you take S, GOTO on S, it would become what? Yes.
S dot S.
So this is also GOTO on
S.
non-terminal. But please remember, GOTO on terminal has a special name. It is also called action. This is also called action, or it is also called shift. This is also called action or shift. But GOTO on non-terminal is always called GOTO. Did you get it? This is the case. If you have any query, you can ask. No query? So I'm going to give you an example. Now everything would be becoming very clear. Let's take this simple grammar. Let's take this very simple grammar. Why don't we take this grammar? S derives okay. Okay, guys. Now we always add a special product before doing bottom-up parser. That is called augmented product. So what is augmented product? We create a new start state, and that is going to be derived to S. This is the augmented product. If we add the augmented product, is the grammar change? Is the grammar change?
Nah,
Yes. Simple. My start state is like this. Start from here. Now I do this. Start S dash. It is directly go to S. So these are equivalent. Am I right? Why did we take these things, augmented product? So that we can start from S. Okay. So let's start. So initially, we start with augmented product and we apply closure on the right hand side of the augmented. Now, what is just after S? What is just after S? George, what is just after S?
dollars.
Dollar. And what is just after closure?
S.
Yes.
So that means I'm expecting a S. Did you get it?
Yes, sir.
So how can you get S? What are the products for getting S?
S dash goes to S.
And what else?
S goes to SS.
S dash goes to S means how can you get to S dash? But how can you get S?
Okay,
Capital S.
Yes,
This
yes.
one.
SS
All
direct.
the products,
Yes.
all the products where the right hand side starts with S. So we are going to write this. S derives SS and A, and also there is a dot over there. That means there is a dot over here and dot over here. Did you get it?
Yes.
Any problem?
Yes.
So again, we have to apply again. So what is just after this closure?
S.
S. So
S.
how can I get S?
Same.
SS.
sdrives.ss. So this product is already there, so I do not need to think. Now, what is just after this closure?
A.
A. Small.
Terminal. So terminal can never be left hand side of context free grammar. So we are done. So this is the closure. Did you get it? We are done with the closure.
কি হলো স্যার এটা?
You will understand what happens. So we have started our journey. Now, using this dot, this closure, we are going to traversing the grammar in such a way so that all the possibilities we are going to find out. All the possibilities we are going to find out. It becomes like a DFA. The whole process, the whole grammar is converted to a DFA. Then what happens? Whenever you are going to give any string, using that DFA, you can find the parsed. Did you get it?
Yes, sir.
Now let's apply GOTO. S dash applying GOTO on S. What do you get? S dash derives. S dash derives. এটা জাস্ট এক ঘর মুভ হবে কি হবে S dash derives
S closure.
S closure. So we are done because it is the final item. Now there should be another one. Let's move like this. If you move on S, then this one become S dash derives S closure. How about this? What would it become? If you move same, here also S, here also S. So same movement. Am I right?
Yes, sir.
Yes, no? So what would it become? S derives?
S closure S.
S closure S.
S.
Good.
S.
Now what is just after closure? What is just after closure?
S.
So we have to again find out the rule where S is on the left hand side. It is nothing but
Yeah.
S derives dot SS or dot A. Did you get it? Now if we
Yes,
apply again the closure S, we are going to back to same rule, so we are done. How about this? If you move on A, what do you get? S derives A dot and it is a final product, so we are done. Did you get it? We are drawing a DFA from that grammar. We are drawing a DFA from that grammar. Now, this is final product, so don't worry. How about this? If we move on S, what do we get? If we move on S, what do we get? What is the first one?
S.
What is the
dash
first one?
derives.
S, not S dash, S
Oh,
derives.
S derives SS closure.
SS closure, so it is a final item, so it stops. How about this? It would become S derives. It is become S derives S dot S. Am I right?
Yes.
Am I right or not? And
Yes.
how about this? What is just
Sir,
after?
তবে তো আবার
Good. What is just after closure? S. So I have to again apply.
S. Yes. Yeah.
Now it is stopped. Because just after the closure there is a S. So if we apply the S again, you come up with the same. So done. Still I have A. If I move on A, go to on A, what do I get? I come back to here. So, all right. Now what? It is done. It is done. It is done. It is done. Now here if I move on S, what do I get? Here if I move on S, what do I get?
SS closure.
Not this one, because it has one extra product. S dash derive S. These two are same, but because of this product, it should not be same. So, moving on S, what do I get? Oh, no, like that. Moving on S, I'm returning back to itself. The same thing. And moving on
Yes.
A, I'm going to. So we are done. Now we are complete. Did you get it? So this is the state transition diagram for LR0 parser for this one. Is there any question you can ask? Any question? Yes, no, no, yes. Did you understand the process?
Yes, sir.
So let's give you another example. Let's take this grammar. S derives A, A derives small a or B. What is the first step? What is the first step? What will be the first step? What is the first step? Tell me. No? What is the first step? What is the first step?
Augmented product.
So, we are going to apply the augmented product. S dash derives S. Then we are going to apply first closure on augmented product. So, what is the case? S dash derives dot S. So, what is just after closure? What is just after closure?
Yes.
So, which rule I have to use? We are going to find out on the left hand side which rule have S. So this rule has on the left hand side S. So S derives dot A. Now just after closure there is a A. So which rule we have to find? We have to find those rules which has left hand side A. So which rule have left hand side A? This one. So A derives. What is after closure? What is after closure? Small a and small b, they are terminal, so they can never appear on the left hand side of the product. So we are done with the closure. Please don't blindly just put the dot, then it's a problem. Just use the logic. Okay? Did you get it?
Yes, sir.
Then what we are going to apply? What we are going to apply? GOTO. The first one is GOTO on S. If we apply GOTO on S, what do I get? This dot is going to move one step further. So what would be the rule?
S prime derives S.
S prime derives S dash, S dot. Is there anywhere S there? No. So it is a single. And it's the final item. Now, how about this? GOTO on A. If we have GOTO on capital A, what do we get?
A closure A is derived
S
closure A.
derives A closure A. Is there anywhere we get capital A? No. So it is the single move. Now, what is just after closure?
A.
Capital A. So we have to find out all those products which have left hand side capital A. Which product has capital A on the left hand side?
A derives
Good.
closure.
So we have to again take this one. And now what is just after closure? Small a, which is terminal. So we are done. What is after this closure? Small b, which is the terminal. We are done. So we are done with the closure. Did you get the step?
Yes, sir.
Now, what is not call it GOTO, let's call action. So what is action on small a? Because we know that go to on terminal is nothing but action or shift. What is
A
the
derives
A derives
small a dot
small a dot a, good. Then what is just after closure?
A.
So
Capital.
which
A
I have to
derives.
find out the rules which have A on the left hand side, capital A on the left hand side. Which one I have to use?
Yeah.
A derives
A derives
dot A.
dot A.
You might say, sir,
Or
these two
dot.
are same. Nah, see, you have to think both. It's like a set. This item and this item are different. Am I right? This item, this one, that's why it is called item. This item and this item are different. Am I right? So as a state, they are different. Did you get it? They have some common part, but if you compare as a set, both of these two states, they are different. Is it clear?
Yes, sir. Yes, sir.
Okay, sir. Okay,
Yes,
sir.
sir.
Now move on A, this is the case. Move on B or action on B, what is the case? A derives, A
B
derives,
B closure.
B dot, and it is the final item. So we don't care anymore because we cannot move any further. So let's number this. It is better to always give numbers. Let's give this on 0, this on 1, this on 2, this on 3, this on 4. All right, guys? Done? So we are doing breadth first searching. From the initial state to breadth first to create 1, 2, 3, 4 steps. Now let's come back here. Let's come to here. It is a final item, so we cannot move further. How about this? How about this? What type of move go to is possible here? Tell me, what type of go to is possible
Is
here?
derives A dash.
Capital
Sorry,
A,
closure.
capital A, then it becomes S derives capital A closer. So done. It is also become a final step. So we don't need to worry about it. How about this? If we move on small a, then why should I go? Why should I go? If I move on small, same, this one, 3, same like state 3. So that means go to on A, small a, we are coming back to this state. And how about this? Go to on B, why should we go?
State 4.
State 4. So we can, that is in further place, so we can write this. So it is done. This one is done, this one is done, this one is done, this one is done. Let's come back here. So what are the possible here? What are the possibilities here? Go to on. Go to on
A, sir.
capital A. Go to on capital A. So if we go to on capital A, what do we get? A derives small a, capital A, dot, and it is the final item. So we do not need to think more. Now, what else we can do? What else we can do? We can have action on small a. So if we have action on small a, we are returning back to the same state. See, A, then it becomes A closer capital A. So, say. And how about B? On B, we are going to this. Done. Done. So that's it. Did you get it? Now it is complete.
Yes, sir.
Also. So this is the way of actually using the concept of closure and go to, we can create the state transition diagram. And Farhim, right? Farhim asked me, sir, what is happening here? The thing is, it is nothing but this whole grammar is actually represented by a DFA. And the DFA is such a way, here we are very exhaustive. We can create any string using this state transition diagram. Did you get it? So that means we make equivalence. This grammar, and this picture, they become equivalent. Okay? Any question? You must ask a question. What is that question you should ask? Sir, why you are doing this thing? Am I right? Why I'm doing this thing? why I convert this grammar to this form. Am I right or not? Yes, no, no, yes.
Yes.
So why did I convert this grammar to this form? Tell me. Why did I convert this grammar to this form?
To take it to DFA form.
DFA form. Why I convert it to DFA form? Why? What is the leverage? Remember. So let's draw the schematic diagram of LR0 parser. Schematic diagram. What is the case? The thing is like this. It would be like this. What is the scheme? Scheme is like this. I have stack. I have stack. I have buffer. Input buffer. Same like before. Same like before. Don't. There is no exception. The stack. Initially stack is empty and it is the empty stack is generated by $. Input buffer. There are a lot of things there, and the buffer is ended by $. Then I have the LR0 parser, which is the algorithm. We are going to find out the algorithm. And we have a table. We need to take a help from a table, which is nothing but LR0 table. To create this table, we have converted this diagram. Did you get it? Did you get it or not? To create this table, LR0 table, we have created this diagram. This is nothing but state condition diagram. All right. So how can we convert this to table? So let's draw the table first. So before that, let's do something. Final items, I'm going to circle. This is the final item. This is the final item. This is 5. This is the final item. So how many states are there? How many states are there in the diagram? Guys, what are you doing actually? Tell me.
There's seven.
7 states are there. So let's write numbers. Fahim used to be very active. What happened to Fahim actually? So what are the states? 0, 1, 2, 3, 4, 5, 6. So at the leftmost column, we are going to write all the states, 0 up to 6. And out of these states, number 1 is a final item, number 4 has a final item, number 5 is a final item, number 6 is a final item. So actually for remembering, I have circled the final item state using a circle. Then we divide the whole table into 2 parts. We divide the whole table into 2 parts. The left part I'm going to call action, and the right part I'm going to call GOTO. So you understand why I called it action and why I called it GOTO. In the action part, I'm going to catch which one? The move on terminal. And on the GOTO, I'm going to catch the move on non-terminals. Okay, what are the terminals there in this grammar? What are the terminals? Small b, and our special one, which is nothing but $. And what are the GOTO? GOTO we have 2, S and A. We do not need to write the augmented one, S dash. Now let's fill in the table. So 0, 0, 0, seeing S, where it is going? 0 seeing S, where it is going? 0
State
seeing
one.
S, going to state number 1. So go to part, we are only going to write the number, which is nothing but 1. Which is nothing but number. Because here there is no shift is happening. Here only go to is happening. We are just going to from one state to another state. And 0 seeing A, again it is a non-terminal. So which state it is going? We are going to write number 2. But this one, the small a is a terminal, and it is going to state number 3. So in this case, we are going to write S. This word S. It means shifting happening, and we are going to state number 3. And B, where we are going? It is also a terminal. We are going to shift. We are going to state number
S4.
4. Good. Now let's go to 2. Let's go to 2. In number 2, what happened? 2 seeing capital A, which is nothing but non-terminal. We are going to 5. So we are going to write here 5. Then 2 seeing small a, which is a terminal. So what would be the entry? 2 small a, S3. 2 A, S3. 2 B, 2 B, 2
S4.
B, S4. Is there anything else? No. 1, 2, 3, 1, 2, 3. 1, 2, 3, 4. Now let's go to 3. 3 seeing A. Why should I go?
3.
3
S3.
seeing A, I should go to S3. 3 seeing B. Why should I go?
S4.
3 seeing capital A. Why should I go?
6.
6. Good. Done. So others are actually final step. So we are done. So remember, in GOTO, we only write down the state because there is no shifting happening. We are just going from one state to another state.
Sir, the
And
6 should be on A. Movement on A. Capital A.
yes, thank you. Thank you. So remember, in GOTO part, we are also only going to write the number because there is no action happening in there. We are changing the state only. On the other hand, when we are getting terminal, we are actually shifting. We are putting that terminal value into the stack. That's why we also write the action, which is nothing but shift. Now let's go to final items. So what are the final items? Final items are nothing but, they are actually nothing but the reaction part. That means they are directly involved with the rules. So let's number the rules. Let's call this one rule number 1. This one SD dash AA. This call SD dash small a capital A rule number 2. And let's call capital A D dash small b rule number 3. Now let's go to 4. Which rule is this?
But 3.
Rule number 3.
Number
So
3.
entire action part we are going to write reduce using rule number 3. Reduce using rule number 3. Reduce using rule number 3. Okay? Now 5. Which rule is this?
Rule number 1.
1. So 5 we are going to write reduce using rule number 1. Reduce using rule number 1. Reduce using rule number 1. And 6, what is the rule? 2. Reduce using rule number 2. Reduce using rule number 2. So this is the table we have created. Still we did not know how to parse, but remember this table. So let's conclude here. So please remember one thing. The action, wait. The action and GOTO part are same in all the parsers or bottom-up parser, all the SR parser. These blue entries are same in all the, you don't understand the blue, I guess. So actually the thing is the action and GOTO entries. Action and GOTO entries are same in all the SR parser, LR0, SLR1, LR1, CLR1. Only difference is happening in this reaction groups. They are changing parser to parser table. So did you understand? Tell me, do you have any question? You can tell me.
So why are we writing reduce like 1, 2, 3 in all three?
Yeah, when we are going to parse, you are going to see why we are writing this row. It means we have already, for example, in 5, it means we have already seen 2A side by side. So we are going to 2A are side by side. So we are going to take this 2A and we make this 2A to S. So that's how we have written these things. Is it clear to you guys? Do you have any more query? Anything else?
So are you gonna give some practice problems?
We didn't start yet. Let me finish this topic first. Then.
Okay.
Alright. Should we stop here today?
Okay.
Okay.
Yes,
So
sir.
let's
It's
take
almost
your
5.
attendance first. Let's take your attendance first. Alright guys, see you then in the next class. Till then, have a good afternoon and take care. Bye.
Good afternoon, sir.
Bye.
Allah.